you people are having microphone. Okay, you people already know how microphone works. You don't know? Let me tell you. Microphone works. First of all, let's supply the voltage we are having. We are giving the voltage simply. um, let's take an example. We are giving the 5 voltage power supply. Okay, this is not the signal. Let me tell you people, this is not the signal. This is just the voltage to power these sensors. Okay, we are giving the 5 volt voltage. Now what is happening? The microphone is uh, first of all, also I want you people to see this thing. ENV. Okay, environment. Now what is happening? 5 volt, we are passing voltage to the microphone or temperature, any sensor that's working analog. Okay, that's producing the analog. How it's working, let me tell you. What is this? An ENV. ENV stands for here environment. Okay, so what's happening here? Environment here refers to microphone. Let's say we are recording our voice. Okay, let's say this video, let's say this the audio currently that I'm recording on my phone. Okay, and the phone's microphone is working analog. What's meant by that? Let's talk about this. When I'm speaking anything, okay, when I'm saying anything, everything is captured by a microphone. Okay, my voice is continuously. Okay, what is meant by continuous? Whatever I'm saying, I'm not saying in instantly. I'm not saying in discrete. I'm saying in continuously. You people are thinking you are taking breaks in between sentences. That's not the discrete. You people see what I'm saying. I'm saying continuously. Okay, the frequency, the way I'm speaking forms a wave. Okay, let's suppose here it makes sine wave. Okay, here it makes sine wave. I am speaking just like this in format. Okay, in sine wave. Every time it's not sine wave. For instance, for now we are taking this example as sine wave. Okay, with respect to the time, the the voice is changing. Okay, now what's happening here? We are the thing is that this microphone is reacting with this thing. Okay, reacting means the microphone is you know microphone is capturing this voice. Okay, now what is happening? The microphone is capturing this voice. Now it produces a signal. Okay, it's capturing what I'm saying. The microphone is capturing. It means this is every time it's not taking. Okay, now what's happening to here? Every time when I am speaking, the voltage is passing to the microphone and it reacts to the environment. It produces an signal. It gives back voltage in the form of signal. Okay, and that voltage we call it as signal, because every time we are saying something, the microphone is recording, and that recording is that the microphone is recording that voice and passing in the form of voltage, and we call that voltage as signal, because every time it's changing, my voice is changing, the voltage is changing according to my voice. According to my voice, the voltage is changing. Okay, so let's say it is giving back um, to us, let's say 3.5 volts. Okay, here this is not constant, every time it's changing. For instance, we are taking as the value as of 3.5 volt. Okay, now what's happening here? We are having the ADC. Okay, we are having the ADC, a machine, or you can say a machine simply, or an electronic component that changes this voltage, that changes this analog to digital, that a computer can understand. Okay, so here what we are having, we are having simply an Arduino, for instance, that is taking these readings and save it to their memory. Okay, first of all, let me tell you, we are not going to in depth about the we are not right now, we are not going to giving the circuit diagram, discussing how this port, how this is working, all that we will go. But for instance, let's understand the basics, how these simple things are working actually. Okay, so what's happening? Every time the microphone is recording, it gives back voltage. Okay, let's not to write here 3.5 volt. It's looking like it's isn't continuous. We are setting here 3.2 to let's say 3.7 volts. Okay, Okay, in this range the microphone is recording. Okay, now what is this ADC? ADC is simply a machine, you can say. It transfers the analog to digital. Simple. Okay, now the ADC, let's talk about this ADC. You know the thing what's happening. Okay, now let's talk about this ADC, what's happening around the ADC and how things are working around ADC. Inside the ADC we are having small electronic components. We are not going to discuss that thing, but we are currently going to discuss the three terms about the ADC. Okay, the first one is steps, the second one is bits, the third one is resolution. Okay, resolution of ADC, bits, steps. Okay, so how these three terms are working actually, let me tell you people, so you people can understand the ADC like this. Okay, so if we talk about how ADC is working, okay, you can simply say it breakdowns the analog and pass and give and breakdowns that come not the breakdowns that continues into small things. So how this is working, actually it's not working. I'm saying just map this thing in your mind. The ADC is working like this. Okay, let's understand how this is actually working. Now to understand this, we are going to take a small pieces of this. What's happening whenever the analog is coming, ADC, the ADC, we know here is coming the analog and here we get the digital ones. That's the in the binary format that the computer can understand. Okay, now what's happening, first of all we have to understand the thing that's called the bit. Now what bit is doing? Okay, bit is doing, so this is an ADC. At the manufacturing time, the bit is decided how many bits of ADC we have to manufacture. Okay, let's say we are having currently an 8-bit processor, 8-bit 8-bit ADC. Okay, and the range from it, the range of voltage, that's the minimum voltage, and the maximum voltage we can call that as reference voltage as well. Okay, let's say the minimum voltage it can detect 0 volts or 2 volts. Let's say 2 volts to 10 volts it can detect. Isn't 10 volt ADC. For instance, we're taking from 0 because we're currently we're having example. That's the 10 volt ADC, and we are having the 8-bit ADC. Now the thing is that how these voltage is divided. We are having one more thing. We're having the step size. That's sometimes we called it as step size means this. It's not the size. You can give it the ladder. Okay, you people know the ladder is always the gradually working, uplifting every time. But here we are having the step size. The step size, exactly, you can resemble this thing with the step size. Okay, now if these simple things are on the ADC. Okay, now what we can do with this thing. Okay, now what we can do with this thing, we are going to do one thing. Okay, let me draw the exact. So let's example, we are having 8-bit processor, we are having these simple things. Okay, in this small gap, and with the 8-bit, let's say we are having the 16-bit processor. For that we are having very close, we can say the distance. Okay, very close, and you people can see we are having very close in 16-bit. This is the 16-bit and this is the 8-bit. Okay, this is the 8-bit and this is the 16-bit.